Okay, so I'm be doing data exfiltration, an introduction to data exfiltration and tunneling technique over various protocols. Welcome to data exfiltration. Cybercriminals use various internet attacks against companies for different purposes. In most cases, many of these attacks end in data breaches, where threat actors steal sensitive data to sell it on the dark web or publish it online. So one may ask, how does a threat actor transfer stolen data from a company network to outside, also known as data breach, without being detected? The answer varies. There are many techniques that a threat actor can perform, including data exfiltration. Data exfiltration is a non-traditional approach for copying and transferring data from a compromised to an attacker's machine. The data exfiltration technique is used to emulate the normal network activities, and it relies on network protocols such as DNS, HTTP, SSH, etc. Data exfiltration over common protocols is challenging to detect and distinguish between legitimate and malicious traffic. Some protocols are not designed to carry data over them. However, threat actors find ways to abuse these protocols to bypass network-based security products, such as firewalls. Using these techniques as a red teamer is essential to avoid being detected. Learning objectives. This room introduces the data exfiltration types and showcases the techniques used to transfer data over various protocols. What is data exfiltration? Understand data exfiltration types and how they can be used. Practice data exfiltration over protocols, sockets, SSH, ICMP, HTTP, and DNS. Practice C2 communication over various protocols. Practice establishing tunneling over DNS and HTTP. Room prerequisites. Introduction to network, protocols and servers, DNS and details, DNS manipulation. Using TM, UX, or similar tools for multi-sessions on single SSH logins. Okay, complete. And next we'll be doing task 2, network infrastructure. For this room, we have built a network simulate practice scenario where we can perform data exfiltration and tunneling using various network protocols. The provided VMs contain 2 separate networks with multiple clients. We also have a jump box machine that access both networks. The following diagram shows more information about the network environment used in this room. All right, so local DNS, jump. So we're going to access this jump box, which is then going to give us access to these 2 networks here, 172.20.0.0/24 subnet, and we have the uploader them.com, victim them.com, flag them.com, and then we have below that the web them.com, ICMP them.com, victim them.com, network 2, 192.168.0.0/24. Use the network diagram for your reference during the coming tasks for various protocols. We have also set the domain name them.com to make it easier to communicate and connect within the network environment. Check the following table for more information about the domain names and network access used in the room. Deploy the provided VM and connect to it via SSH client by deploying the attack box or connecting to VPN. Use the following credentials to connect to the jump box with access to the internal network. So machine IP, user them, TRYHACKME. So let me start my machine up. Once you have connected to jump box, you'll have access to both networks. Check network infrastructure for more information. Lab recommendations. We recommend using the jump box and the network environment for most tasks, TCP, SSH, ICMP, and DNS to avoid technical issues with DNS and networking. However, if you prefer to use the attack box for the DNS tunneling task 10, you must challenge the DNS settings of the attack box to the machine IP. For more information about changing DNS for attack box, check the DNS configuration task 8. Got it. In most cases, we will need to use 2 machines to establish communications. Thus, we need 2 or more Linux terminals available to complete the task. Therefore, we recommend using the TMMux tool for creating multiple sessions over a single SSH login. Once you've deployed the VM, please wait a few minutes for the VM and the network to start, then progress to the next task. Okay, so we'll go ahead and state correct answers. And then here we have the network. And what I'm going to do is I'm going to SSH into this jump box, ping a few of these, and make sure that I'm getting connectivity. All right, so let me go ahead and pull up my VM. All right, so here's my VM. I'm going to go to my script. Let's see here. Now my desktop, it's not exactly arranged the way I like it, so I'm going to arrange it by alphabetical order. All right, now I can see my Area 51 script, which is really just the script I use to connect to TRYHACKME's VPN. So I'm open up a terminal here, and I've created a bash script that will allow me to connect to their VPN rather than having to navigate to the OVPN file. So I'll go ahead and initiate that. All right, so here it is. As you see, all I've done is I created the script open.sh, and whenever I launch that and input my password, then I am granted access to the TRYHACKME network. So what I'm going to do next is just make sure I get ping. And if you're interested in making that script, go ahead and look at the description below. I'll go ahead and put a link to that video so you can take a look at it. It's pretty helpful. Anything that I could script, I'm going to end up scripting because I don't like doing everything manually all the time. So it tells us we can SSH into this attack box. Let's go ahead and give it a shot without having to change our DNS configurations just yet until task 8. So, okay, I'm just going to go ahead and try SSHing in. So I just did SSH them and then the IP address, just like they show there. And it's kind of stalling. It's not doing anything. Interesting. All right, let me try that again. I have a feeling I'm gonna have to adjust some settings here for the DNS, but well, I guess we'll see. There we go. So try it a second time, type yes. Now it's asking for the password. I'm going to put in the password that I have here. All right. And because I don't have a lot of time to do this, so I'm only going to spend about an hour of my day today, which I've already burned through 20 minutes, actually setting this, doing as much of this lab as I can. And then if I can't finish it, then I guess that's what tomorrow's for. So please like and subscribe because I am doing this, you know, even though I don't have a lot of time in my hand, and I'm doing it for you guys. So let's go ahead and continue on with this. All right, so next you see task 3, data exfiltration. And I think this is the only task I'm gonna be able to do today. What is data exfiltration? Data exfiltration is the process of taking an unauthorized copy of sensitive data and moving it from the inside of an organization's network to the outside. It is important to note that data exfiltration is a post-compromise process where an attacker or a threat actor has already gained access to the network and performed various activities to get hands on sensitive data. Data exfiltration often happens at the last stage of the cyber kill chain model, actions and objectives. All right, data exfiltration is also used to hide an adversary's malicious activities and bypass security products. For example, the DNS exfiltration technique can evade security products such as firewalls. Sensitive data can be in various types and forms, and it may contain the following: username and passwords or any authentication information, bank account details, business strategy decisions, cryptographic keys, employee and personal information, project code, data. How to use data exfiltration. There are 3 primary use cases for data exfiltration, including exfiltrate data, command and control communications, tunneling. Traditional data exfiltration. The traditional data exfiltration scenario is moving sensitive data out of the organization's network. An attacker can make one or more network requests to transfer the data, depending on the data size and the protocol used. Note that a threat actor doesn't care about the reply or response to his request. Thus, all traffic will be in one direction, from inside the network to outside. Once the data is stored on the attacker's server, he logs into it and grabs the data. Okay. All right, so we're exfiltrating the data out and over to our server. C2 communications. Many C2 frameworks provide options to establish communication channels, including standard and non-traditional protocols to send commands and receive responses from a victim's machine. The C2 communicates a limited number of requests where an attacker sends a request to execute a command in the victim's machine. Then the agent's client executes the command and sends a reply with the results over a non-traditional protocol. The communication will go in two directions, into and out of the network. Right. Tunneling. In a tunneling scenario, okay, so you use the C2 and you command it to exfiltrate the data, essentially. In tunneling scenario, an attacker uses this data exfiltration technique to establish a communication channel between the victim and an attacker's machine. The communication channel acts as a bridge to let the attacker machine access the entire internal network. There will be continuous traffic sent and received while establishing the connection. In the coming task, we'll discuss the following techniques and use cases. Exfiltrate using TCP sockets and base64, exfiltrate using SSH, exfiltrate using HTTP, post request, ICMP, and DNS. In which scenario will sending and receiving traffic continue during the connection? All right, so traffic continues during the connection. I would say tunneling for that one, because once you establish that tunnel, then you can continuously send traffic. All right. In which case scenario will sending and receiving traffic be in one direction? All right, let's see. So C2 communication, traditional data exfiltration, right? So you connect to their machine, you have exfilled out to your server. So that's gonna be traditional data exfiltration. All right, so I'm gonna put that one in there. Also, you know, because I mean, it looks like that's the only one that would fit in there. In the next section, we'll be discussing how data exfiltration over TCP socket works. Okay, complete. All right, now we're getting our hands a little bit dirty here, hopefully. Exfiltrate using protocol. Actually, no, it doesn't look like we are. Well, that sucks. Okay. This task shows you how to exfiltrate data over TCP using data encoding. Using the TCP socket is one of the data exfiltration techniques an attacker may use in a non-secure environment, where they know there are no network-based security products. If we are in a well-secured environment, then this kind of exfiltration is not recommended. This exfiltration type is easy to detect because we rely on non-standard protocols. Besides the TCP socket, we will be using various other techniques, including data encoding and archiving. One of the benefits of this technique is that it encodes the data during transmission and makes it hard to examine. The following data diagram explains how traditional communication over TCP works. If two machines want to communicate, then, oh man. Okay. There. Okay, there we go. Then one of them has to listen and wait for incoming traffic. It is similar to how two people talk and communicate, where one of them is listening and the other person is speaking. TCP socket, 22 SSH. Right here, listening on TCP 1337 TCP socket. Connect to 1, 2, 3, 4 on TCP. So looks like we're doing a reverse shell here. So it's connecting to our computer here. And then read the established connection. Okay. The diagram shows that two hosts communicate over TCP on port 1337. The first machine is listening over TCP port 1337. The other machine connects to the port specified in step 1. For example, in C 134, 1234, 1337. Okay, yes, let's do an reverse shell. The first machine establishes the connection. Finally, the sending and receiving data starts. For example, the attacker sends commands and receives results. Okay, so basically you get a reverse shell and then you send commands to it. Communication over TCP requires two machines, one victim and the attacker machine to transfer data. Let's use our network environment to practice sending data over TCP. To establish communication over TCP, we require two machines. The victim1 them.com machine is the victim, and the Dropbox jump them.com is the attacker machine. Okay. First, we need to prepare a listener on the jump box on a port you specify. In our case, we choose 8080. All right, got it. So if you haven't already, make sure you do that SSH connection to the jump box. And what a jump box is it's essentially just a computer that you connect to, and then once you connect to that computer, it allows you access to another resource, right? So here we go. And see, I'm gonna just copy this. And so it looks like we're setting up a reverse shell on this one. Or we're setting up a listener. And let me see if it works. Okay, so it's listening. From the previous command, we'll use nc command to receive data on port 8080. Then once we receive data, we'll store it in the temp directory and call it task for cred data as a file. Now let's connect to our victim machine that contains the data we need to be transmitted using the following credentials. Note that to connect to the victim from the jump box, we will use the internal domain as followed. Okay. So it looks like we have to have multiple connections from our jump box. All right, let's see if I can do that. I don't know if it's gonna let me. That's why they mentioned installing some software to do that, I guess. Let's see if it lets me. Here we go. So what I'm gonna do is I'm gonna go over here and I'm gonna copy over the passwords. All right, I always recommend copying this stuff over to a notepad as you're going through it so you don't have to keep going back to task 2 for that information. And I guess we'll start another SSH connection. So let me give that a shot. So this is the password, TRYHACKME. All right, throw it in there. Permission denied. Oh, I had a few spaces in there. So yeah, when you copy it, make sure you don't have spaces, I guess. Let's see if that works now. Yay, I'm in. All right, cool. So next we're going to SSH into victim1. We can also connect directly from the attack box using port 222. Oh. I think we'll use our victim in this case, because in the real life, I feel like you wouldn't use your attack box. You would probably use the victim to do all the talking, because if they start seeing traffic coming from an external computer, I mean, like, I'm pretty sure they're already seen that, but if they start seeing that from multiple computers, it might raise an alarm. Or if you see it from one and it's occurring over a normal port, then it may not raise alarms. I don't know. So let's go ahead and SSH into this other computer. All right, it's asking for victim one's password. I'm guessing that's the same. I really hope so. Hope they don't change up the passwords here. All right, so it looks like we're in there, and you can tell because the name here says them victim one, THM them. Yep. All right, and we have required data ready to be transmitted on the victim's machine. In this case, we have a sample file with a couple of credentials. All right, so it looks like we have some files. And by the way, data exfiltration is really just backing up the data. We're just backing it up on our computer, you know what I'm saying? Like we're hacking into this computer and backing it up somewhere else because we're so nice for them. We're so nice, right? All right, so let's see. Oh, we got some passwords in there. Yeah, you definitely want to back that up on my computer. All right. Now that we have the credential text file, we'll use TCP Socket to exfiltrate it. Make sure the listener is running on the jump box. All right, so tar task 4 base64. Let's see what this is doing. Let's break down the previous command and explain it. We'll use the tar command to create an archive file with the zcf argument of the content of the secret directory. Okay, so we're making that archive file. The Z is for using gzip to compress the select folder, and the C is for creating a new archive, and the F is for using an archive file. Oh yeah. Okay, so you're using tar followed by the commands for tar to gzip it. Obviously, you want to compress that thing. We will then pass the created tar file to a base64 command for converting it to base64 representation. Then in step 4, we'll pass the results of the base64 command to create and copy a backup file with the dd command. Okay, so we're making a copy of it with the dd command. Got it. Using the EBCDIC encoding type, right? So dd followed by the encoding type. 5. Finally, we will redirect the dd command output to transfer it using the TCP socket and on the specified IP and port, which in this case is port 8080. Okay, so we're then compressing it, base64ing it, copying it with DD in the EBCDIC format, and then we are going to send it over to the reverse shell that we have going on right now, the netcat. All right, note that we use base64 and EBDIC encoding to protect the data during the exfiltration. If someone inspects the traffic, it would be a non-human readable format and wouldn't reveal the transmitted file type. Once we hit enter, we should receive the encoded data in the temp directory. Sweet. All right, this is like James Bond stuff right here. Let's try it out. Let's give it a shot. Here we go. Yeah. All right, let me grab that and throw that in there. And then cross my fingers and send it. All right, I think that worked. Yeah. All right, so then I'm gonna go over here. I'm gonna move this over here, and then we can see that we receive the connection on victim them1. All right, cool. And what's this gonna ask us to do next here? The following is an explanation of the previous command. We used the dd command to convert the receive file to ASCII representation. We use the task 4 cred data as input to the dd command. The output of the dd command will be passed to base64 to decode it using the -D argument. All right, so from the dim text box here, we're then going to run cd temp so we can move over to our temp directory. So I'm gonna go ahead and put that. And then after we move over to temp directory, then we're going to use dd, convert to ASCII, task force credential data, base64. All right, and then finally we save the output in the task4 creds tar file. Next, we need to use the tar command to unarchive the task4 cred tar file and check the contents as followed. All right, so we're gonna do that. Okay. And then we'll run this command here to unarchive it with the xbf command there. And there we go. Now we've unarchived it. And tar in this case isn't really compressing it as much as it is just combining these files into one location. That's what it's good for, and it's also good for compressing as well. But anyhow, let's see here. Now let's confirm that we have the same data from the victim's machine. Okay, so then we go to, we'll cat the file out so we can see what's in it. So what we've essentially done is we've taken it from one file to another file using TCP in this case, a TCP socket. Alrighty. Huh. All right, cool. Which is the one that we opened, right? And that's how we were able to get it over to our listening netcat session over a TCP socket that we specified. And now I'm gonna cat that out, and then we can see we have the contents that we wanted. So we transferred it from one computer to another computer. Success, we have exfiltrated the data from a victim's machine to an attacker's machine using the TCP socket in this task. Okay, cool. I mean, was our, yeah, okay, gotcha. All right, cool. So, using the exfiltration using TCP socket relies on what protocol? It relies on, and I have to scroll up because I don't remember. Let's see. Let me read through this again. All right, I'm just gonna do whatever I do when I don't know the answer. I usually just type protocols keyword here, and I see non-standard, so I'm gonna go with that. And I feel like that's gonna work. Let's check it out. Yeah, it worked. Now apply what we discussed to exfiltrate data over the TCP socket. Once you exfiltrate, successfully hit complete to move on to the next task. Okay. All right, well, we followed along the process, so we've pretty much done that, right? All righty, so on to the next task, and I still have 15 minutes, so let's see how long this task is. Okay, this one's not that long. might be able to do this one. All right, let's give it a shot. In this task, we will show how to use SSH protocol to exfiltrate data over to an attacking machine. SSH protocol establishes a secure channel to interact and move data between the client server, so all transmission data is encrypted over the network or the internet. Okay, to transfer data over SSH, we can use either the secure copy protocol or the SSH client. Let's assume we don't have the SCP command available to transfer data over SSH. Thus, we'll focus more on SSH client in this task. Oh, I love SCP. Too bad we don't have that. As we mentioned earlier, an attacker needs to control a server, which in this case has an SSH server enabled to receive the exfiltrated data. Thus, we will be using the attack box as our SSH server in this scenario. You can also use the jump box since it has SSH server enabled. Let's assume that you have gained access to sensitive data that must be transmitted securely. Let's connect to the victim 1 and victim 2 machines. Let's use the same techniques we discussed in exfiltration using TCP Socket task, where we'll be using the tar command to archive the data, then transfer it. Okay. All right, cool. All right, so it looks like we're doing the same thing in this scenario, except we're connecting to victim 1 and 2. So let me show you the way it looks right now. So this is my attack box, or this is the jump box terminal. This is victim 1's terminal, which if I wanted to, what I can do is I can just clear it. So I have a more clean terminal. Dang it, I should have kept that. I should have kept that because I like to put the stuff in my notes. So all right. Well, too bad. I already deleted it. Dang it. All right, so next, what we'll do, and go into victim 2. Okay, so we're going to create another session. So let me open up another terminal. And since this is the same thing, it really shouldn't matter. I guess these notes would be good for both of them. And they did spell it out pretty well for us here, so I really don't need to make my own notes, I guess. So let's back up here. All right, so we're getting a connection to victim 2. Got it. So let's go ahead and SSH into that. And I'll pause it. All right, so in order to connect to victim 2, I'm gonna have to copy and connect back to my jump box. And once I connect to my jump box, then I should be able to connect to victim 2 from here, right? So let me connect to victim 2. So I'll just do this, hit the upward arrow here. All right, let me copy this, paste that in there. And I think just the host name will work. Maybe the IP address will need to be inputted. Let me see, did we put the IP address last time? No, we didn't. Just put the name of it. All right, so that should work then. So I'll go back over here. And then for future reference, I'm just gonna copy this into my little notepad here. And we'll change this. That'd be victim 1, 2. I don't have to retype this stuff out all the time. So this just works out for me. All right, and paste that in there. And yes, should be the same password. TRYHACKME, paste that in there. Ah, dude, that's not gonna work. I put a space in there. Oh my gosh. Okay, try that again. In the real life, I would have locked myself out by now. They would have found me. All right. All right, so we're connected to victim 1 and victim 2, and then we'll need to prepare a listener on our jump box, right? So we'll prepare a listener on the jump box as well, which if I remember clearly we did last time already. We had a listener here, so I'm redo my listener here. Okay, so I got my listener going again, again, and then from the previous command we used the nc command to receive data on port 8080. Once we receive the data, we store it in the temp directory and call it task4 creds data as a file name. Now let's connect to our victim machine that contains the data that needs to be transmitted using the following credentials. Yep, done it. Note that to connect to the victim one from Jumpbox, we'll use the internal domain as followed. Got it. We can also connect directly from the attack box using port 2022. Okay. Got it. All right. So I mean, we could connect to victim one from your attack box as well. I'm not doing that. We have the required data ready to be transmitted on the victim's machine. In this case, we have a simple file with a couple of credentials. Okay. So we have some credentials here from victim one. So over to victim one, paste that in. Let's check out those credentials. Looks the same to me. I guess victim two has the same credentials as well. Ooh, whoops. All right, here we go. Let's cat that out, see if they have the same credentials. Oh, yes, they do. Someone tells me that's the same user. All right. Now we have the credential text file. We'll use the TCP socket to exfil it. Make sure the listener is running on the attack box. Okay, so then we're just doing the same thing here. tar zcf task4 base64 dd, copying it to the ecbcdic format, and then sending that over to our dev temp IP address of our jump box port 8080. I literally feel like I'm doing the same thing at this point. What's the difference? Oh, creds. I'm following the wrong instructions here. All right. But that's good. I mean, I'm set up for task 5. I'm pretty much set up for that, right? They did say it was the same steps, so let's transfer using the same techniques we discussed using the TCP sockets. We'll be using tar command to archive data, then transfer it. Okay. All right, so here, actually this is task 5 credentials. Sorry if I confused anybody, but task 5 credentials, which is the same credentials apparently. Yes, it is. It's literally the same credentials. All right. And then we'll transfer that over using the tar command. Let's break down the previous command and explain it. We use the tar command, the same as the previous task, to create an archive file of the task 5 directory. Then we pass the archive file over to the SSH. SSH provide a way to execute a single command without having a full session. Got it. We pass the command that must be executed in double quotes, cd temp. Oh, cool. So we archive it, SSH into the jump box, and then we run a command in quotes that will cd into the temp directory and then tar that file. In this case, we change directory and unarchive the past file. Okay, right, so you unarchive it. Got it. If we check the attack machine, we should see we have successfully transmitted the file. So then we go to our jump box and check task 5 credentials, and it's there. Okay. So literally the same command. Cool, let's do it. So here we go, except we're using SSH. Huh. I think it's gonna ask me for my password in this case. So it's the same thing except only using SSH. Ah, got it, okay. So not exactly the same, but pretty much the same. So we didn't have to set up the listener that we did earlier, but it's fine. I can use that for my notes. So yep, and it's gonna ask me for the password. Copy and paste that. Send it. All right. So it looks like that should have worked for victim 1. And then we'll do the same for victim 2 to just reinforce it. All right. Take the same command. Paste it in there. Run it. Get password ready. Come on. Huh. All right. So my terminal is freezing up on me for some reason. And type yes. Maybe it's stuck there. Yeah. Oh well. We'll just move on. As long as we get victim 1's data, I think we should be good. So we'll just go ahead and cd over to task 5 from the jump box. Right, so that's victim 1, victim 2. I should clean this up, guys. I really should. I should do this. I should just grab that, put it over here, take victim 1, put it over here. And then we'll kind of do away with victim 2, so I'll just minimize that one. Okay, here we go. And we have a listener on our jump box, so we'll just close that listener out. And we'll just navigate over to our folder. And then we will ls it. So you can see what's in there. You can see the creds in there, creds.txt. So I'm my cat creds.txt. Yep, there it is. All packets sent using the data exfiltration technique over SSH are encrypted. Yes, because it's done over SSH. Replicate these steps to transfer data over the SSH client. Once you transfer the file successfully, complete well on the next task. Done. Done. All right. So it's been an hour, so I'm done for today. I'm gonna make another one tomorrow, hopefully going over the rest of this. I still need to do my notes, so that takes me a good 10 minutes. Anyhow, if you guys are wondering like, oh, what do you mean by notes? Well, actually I have OneNote, and what I do is I just copy all of my notes over to OneNote, and if I ever come across a CTF where I need to transfer data, I can just type in SSH here, and then it can quickly take me to my notes that have the instructions on how to do that. So this is extremely quick. It's better than Googling it because I have it right then in there in the format that I understand because I was the one that created the notes. Highly recommend you do the same. And it's really helped me in a lot of scenarios. What I'm starting to do is I'm starting to do easy CTFs and just rely on my hacking methodology that I've developed. And as time goes by, I'm going to start going from easy machines to medium, and then from medium to hard. And so as I continue, my hacking methodology continues to develop. My notes get better and more organized, of course. And so that's kind of like a way you can go about it if you're trying to study for the CEH or the OSCP, is developing your hacking methodology. Because at the end of the day, that's all that really matters. Having a hacking methodology, knowing how to utilize the tools, and being competent enough to actually overcome challenges. That, to me, so far from what I've learned in the few months that I've been doing this, is the key to success. So I'm going to keep pursuing uh, pursuing that. And if you have any tips or tricks, throw in the description. Go and throw it in the comment section. um, and like tell me what's your methodology. How are you going about this? I'm really interested in hearing more and having a conversation with my audience. So I'm just gonna go ahead and move this over to the side, and I think we're good here. All right, Danny out. Have a good one.